Actually, I lower the temperature. I think I keep mine at 100 degrees. So they stay in there. They have I think what are the doctor's warnings? You're only supposed to stay in a hot temp for like what 15 minutes. Or nobody stays in there for just 15 minutes, but that's like what they say. Well, I stay in there for like 2 hours. I get like a couple of episodes of something. So you can't, if it's 102 degrees, you start getting lightheaded about maybe 45 minutes in, hour in. Yeah, so I drop it to 100. But what's awesome is when it's like, like 2 outside. Yeah.
My grandpa's one in Florida, and he goes there in the winter only. And he came back one time. There was like 20 dead frogs in his hot tub. He was floating there.
Did he still go in?
I don't think so.
Well, filter will take care of that. Florida does not seem like the right place to have an outdoor hot tub.
I think it was like on a deck, and he just didn't have it closed.
Well, but even then, I mean, like if you're out in Florida's like hot. It's like even in the winter, it's like warm in Florida. So I'm not sure that's hot tub weather. It's like pool weather. Florida's a good place to have a pool. Huh?
It's hot tub weather.
You think?
But it gets in like the 60s.
Oh, so you've adapted. So you've done what the old people do.
Uh-huh.
See, like my grandparents, they were from Philly. They retired down in Fort Lauderdale. And now they can't leave that environment. My grandma's bundled up like it's like 10 degrees here when it's like 75. She's acting like it's death. I go down there most Januaries and I golf. And not this past one, but the last year I played had a course down there, a pretty nice course, and it was like a really bad, well, by their standards, it was cold and windy. So this is the middle of January, so it was like 65, and kind of windy and a little bit of rain. Well, I'm wearing shorts and a golf shirt. 65 degrees. The bag drop people looked at me like I was crazy. I pulled up and they're like just bundled up, like basically trying to survive. Like, what are you doing?
That's like when I went down to New Orleans.
Yeah,
And
that's hot down there.
yeah, I was down there like during late July, August, and I came back up here. It was freezing, so I was wearing like a black hoodie, and my mom was like, "You're gonna get heat stroke."
Yeah, I think the only times I've ever been to New Orleans have been in like July. And it's like almost 100 degrees and 1,000% humidity. It is so hot. Like I remember walking in from the parking lot to a Walmart, and when you get to the door, they actually have the air conditioning starts outside. So they want you to not drip sweat in their entrance, I guess. And you get in there and everything's fogged up and your glasses and stuff just because I went for like a 60-degree temperature change or something like that. But it's the humidity is what gets you. But yeah, it's hot. Good food. Oh my gosh, good food in New Orleans.
I actually missed out on having used crocodile soup or something.
Okay.
I missed out on that. So it was kind of bummed
Except I'll tell you what, New Orleans is the worst place to go with my wife though. She's not a very adventurous eater. She doesn't like anything spicy at all. Like at all. So like we have to go to these boring places, or she just sits there and gets mad at me. So I'm sitting there eating this awesome stuff, and she's like just eating bread, and complaining that it's spicy. What do they put on the bread? All right. That was my own opening act. Okay, so homework was to add end, remove end. How'd that go? Better than the previous assignment? Now we're able to output to the screen a little bit, or that didn't work out?
GitHub's still hard.
GitHub's still hard?
It took me forever to realize how to push it. It says committing it and not pushing it. Didn't realize it was like a drop down.
Okay. Well, did you figure it out eventually?
It took me half an hour to do that part of it.
Oh, well, but did you eventually figure it out?
Yeah, I think I'm not sure if well, for our assignments, I think it'd be I don't know how it would work without forking it from yours and then changing the name, because like in Android Studio, if it's listed as the same name as what you had before, it's not gonna
Oh, I get it. I get it. So for each assignment, you're trying to push to a different repository.
Yeah.
Okay, I get it. I mean, GitHub is kind of made for doing this. I mean, what you might do, and maybe you still wouldn't want this. It just, I guess this becomes a personal preference, but you could keep pushing it to the same repository, but change the comment in the commit to, homework number 4 or something like that. So then you'd be able to see the versions of it. But as soon as you start getting more than one, multiple files, then I can start seeing that becoming a problem. So it seems like the thing to do then is can you fork your own repository and give it a new name and then check it out under the new name? So like fork homework 3, name it homework 4, check out homework 4, make your changes and then push back to homework 4.
I mean, I fork yours, and then once it's on mine, then I rename it so that it's not the same thing,
Okay.
and then I pull it down and push it back up to mine.
All right. So you kind of have to just play the GitHub game somewhere in there. All right. So did everybody at some level figure out kind of their way of doing GitHub-ish thingamabob stuff? Huh? Okay, I think that's what you're saying, right?
What?
Because she's saying it kept trying to push it back to mine.
Yeah, or it was, like the previous assignment, when I put it on mine, I left it the same name as what you had originally.
Okay.
And so,
Which shouldn't be a problem.
right, and that worked that time, but then for the next assignment, I didn't want to overwrite or
Yeah.
put it on the same paper.
Well, so I think then when you check something out, if you go up here and instead of saying commit changes and push, I think what you can do is you can go in and import into version control. And then you could say share project on GitHub, and I think it'll let you name it then. And I think that'll create a brand new project. It won't?
Not for me.
It'll say it's already on there.
Yeah, and then the link takes.
All right, well, here, let's try it. So, okay. So let's see. Is there a workaround? Create Git repository. So that'll do it local. Okay, so let's go to GitHub here. So what happens if okay, so I can't fork it in my own repository. Okay, so but when you forked mine into yours and then checked it out from yours,
I checked it out after I renamed it on mine.
okay, but you said it kept, so you pulled my repository down. You didn't do a fork, right? Okay, so you pulled it down, which is fine. So you pulled this down inside here. So the thing is, I don't know how to disassociate. How do I log out of GitHub on here? So if I can log out of GitHub, I might have a better shot at yeah, here, okay. So let me just remove my account information there. And then we'll hit OK. And then I'll import into version control, share project on GitHub. So I think the idea would be that you can check mine out, then you should be able to import into GitHub into your account, and that should at least work, right? That works. So the issue then is, how do you keep building on your last week's project, last homework assignment, but deploy it to a different GitHub account? That's where the rename thing comes in, right? So do you rename it on here?
I just did it on the GitHub.com.
So you go to GitHub. Will it let me? I guess the question is, can I duplicate a repository? Oh, you know what? I bet you the thing to do is this. It's probably to create a branch. So this is the original branch. So I create a second branch on here. Settings, maybe? Branches. Well, maybe I can't do it on here. I have to do it from the project. So if I go here, well, what's this? Rebase my GitHub fork? What does that do? Oh, I didn't fork it. Okay. Git. Can I create a new branch? New branch. CSC300. What homework assignment was this? 3? 4? Homework 4. I'll put the spring 2016 underscore homework 4. All right, so that creates a new branch. Now I should be able to commit changes. Oh, let me make some changes. Oh, here. Changed. New branch for homework number 4. Commit. Here's your commit and push thing, by the way. If you just hover over the commit button, you can do both right here. Is there anywhere on here where I choose what branch this is, or is it? Let's do it. Okay, so this is the let's see if it puts in a brand new branch. So it says yep, so it created a new branch on here. So I can look at it from the perspective of homework 4. So I think that's the way to do it to make your life relatively easy. So now you have a single repository involving linked lists with all the homework assignments involving that branch. Well, having multiple branches, one for each homework assignment. The idea for branches is that, let's say you have a software product that's released, so you might have like a stable branch, that's the one that's actually out, and then you might have a beta branch that you're working on. That's the one you're testing and you haven't actually released it to the public yet. And then at some point you can make that the new default branch. So when people check it out, they'll pull from that. So I think that's the maybe a solution. Let's go with that. Okay, so let's look at this. So we are supposed to write add end and insert linked list. Let's give some space here. Add end and remove end. So we have add front. We have remove front. We wrote those last time. So now let's go ahead and let's write add end. So public void add end, and this guy takes in a string value. Does that match kind of what we did up here? Yep, string value. Okay. So first thing we're going to ask is we can do something like if this dot head is equal to null, that is if this is currently the empty list, let's just add front, since we already did that, right? If we're dealing with the empty list, there is no difference between adding front and adding end. Otherwise, if there's at least one thing in the list, that's the situation we're in here, right? There's at least one thing in the list. I have some work to do, so I'm going to go ahead and create my new node. I have to give this guy the payload, right? All right, so that's my new node. Now I need to go and traverse my list till I get to the last guy in the list. So if we go back to our picture here, if my list currently looks like, well, let's say my list currently looks like this. I'm going to have a variable here called kernode. So I'm going to make kernode point to head. So both of those guys point to the same place. And what I want to do is I want to keep moving kernode down the list over and over and over again until I finally get to a place where kernode's next node is equal to null, where it points nowhere. All right, so my first step is get this guy positioned where he needs to be. So I ultimately want him pointing there. Then I can make this guy's next node point to my brand new guy. All right, so let's get kernode down the list now. So we'll create a node, kernode, start that off at head, while kernode dot get next node is not equal to null. So as long as kernode has a next node, go ahead and update kernode to be his own next node. All right, so what does that code effectively do? It does this. We start off at equal to head, while kernode dot get next node is not equal to null. Is kernode's next node something other than null? It is, so set kernode equal to his own next node. Loop back up. Is kernode's next node something other than null? It's not. In this case, it is null. So we're done. So now we just fell past this while loop. So we're sitting right here. Kernode is currently pointing at the last node in the list. And what do we do from that position? We have to hook up our brand new guy that we already built. So we're going to set kernode's next node equal to n. Make sense? So this should be able to add things to the end of our list now. So let's go test that. So go into our main activity. I'm doing a couple of different displays now. We added everything to the list, so this should be 4, 3, 2, 1 in our list. Displayed it. Then we removed one thing, so the next list should be 3, 2, 1. Then let's go ahead and add a couple of things to the end. Add end. Let's just do 6, 7, 8. All right, so now we should have the list 3, 2, 1, 6, 7, 8 when we display our last time. Let's go ahead and run this. Three, 2, 1, 6, 7, 8. All right, so that's our add end. Questions about that? All right, so now remove end means we need to do the exact same thing to get all the way to the end of the list, except we want to come up one short of that, right? Because if I'm going to remove 8, moving kernode equal to down here means that I'm going to be sitting on the 8. Well, how do I remove that guy that I'm currently sitting on? So we can do this a couple different ways. We could use 2 separate pointers. So for instance, if my list looks like this, I can use the same logic I currently have and move kernode into place. And then I can have a previous node and have this guy keep traversing down the list until his next node is equal to kernode. Make sense? Similarly, I could use one node and I could keep going as long as kernode's next node doesn't, as long as kernode has a next node and kernode's next node is not equal to null. So I can do 2 steps there, right? So as long as kernode's next node, as long as kernode has a next node and that next node is not equal to null. So let's look at that model. So we'll move pre-node off of here. So when I'm sitting here, does kernode have a next node? Is his next node something other than null? Yes, so I'll go ahead and move. Does kernode have a next node? Yes. Is his next node something other than null? Well, does his next node point to something other than null? It does not. So we're done. Kernode's in the position we want him in. Okay, so we kept moving. Now, what would happen if we had a 1 list? So let's just assume this guy was pointing out to nowhere. Now I'm going to say, we'll start kernode at head. Does kernode have a next node? Yes. Is kernode's next node point to something other than null? No. So kernode's exactly where we want him. All right, so even on a 2 list, we're still okay with that logic. What if it's a 1 list? Does kernode have a next node? He does not, even from the very get-go. In our other example, would we ever be in a position with kernode where he did not have a next node? We had it like this. Kernode is never in a position other than a 1 list when he does not have a next node. We could have a situation where we don't move because his next node points to null, but he always has a next node. in that situation. So in the one list, we're going to treat this as a special case. Okay, when this guy's a one list, we're going to treat it as a special case. That is the case when head points to something, but head's next node does not. All right, so we want to know, are we the special case to begin with? Oh.
A special case for 0 list, for an empty list.
Well, yeah, you could ask if head is null. If head is null, you're going to just return null. We probably did something like that for our remove front, didn't we? Node to return is this dot head, which would be null. If head is not equal to null, then update this, and then finally return node to return. So if head was equal to null, well, actually this could be a little dangerous here. This is actually poorly written. Because in remove front, we'll start node to return pointing at the same thing as head. But if it's the empty list, which means head points to null, we'll fail this if statement. Fine. But the very next thing we try to do is we try to set node to return's next node equal to null. Well, in that particular case, node to return is the null value. Null values don't have a set next node. So this should currently crash. If I go back in here and let's just comment out, well, here, that's fine. I'll just go ahead and remove front. That's good enough. So now I'm trying to remove front from the empty list. It should crash on us, which isn't the desired effect, but that's what it'll do. It's actually already, oh no, it hasn't. There we go. Here's our crash. Null pointer exception. Trying to see where it actually says the null pointer exception. Oh, here it is. Null pointer exception. All right, because we tried to invoke a method. That is, we tried to call the method setNextNode on a null value. So really, this guy should be in here. So if this dot head is not equal to null, we already have node to return equal to this dot head. Then we'll update this dot head to be the next node, so it's pointing to the next place in the list. And then we'll update node to return's next node to be null, disconnecting it from the list. And then we'll ultimately return node to return, which in this case would return a null, which is fine, as long as we haven't actually tried to call any functions on a null. All right, so this should not crash now. So we had a poorly written function there. I was testing you. You all failed. Anybody fix that in their code? Oh, you wrote this better beforehand? less errors? See, I purposely inserted a runtime error to test you. All right, so this guy should launch. Yeah, so it didn't crash. It showed us the empty list even after we tried to remove from the front of that guy. It just didn't remove anything, right? And then we did our 6, 7, 8 for the next part of the list. All right, so remove front is now fixed. Let's go back to remove end. Wasn't I in the process of writing it, or did I not write it yet? So we're going to have public node remove end. And this guy is going to, well, not do anything if it's the empty list. So right off the bat, we can do this. We can say if head is equal to null, we can just say return head. So we're going to return a null value just like we did before. If we don't have anything to remove, let's not try to remove anything. Okay? Otherwise, let's try to remove stuff. So the next thing we need to do is we need to deal with the one list special case. Okay, that is the case where head is actually equal to something, but his next node points nowhere. Okay? So if head dot get next node is equal to null, that means we're dealing with a one list. So if head exists, we wouldn't be in this if statement, and we wouldn't be in this else if head was equal to null. So in this case, we know head is something. Now we're asking the question, does head have a next node that points somewhere? Is it a two list? If the answer is no, that means it's the one list will be inside this if statement. So if it's the one list, what are we going to do? Well, we're going to say, actually we can probably just do this here. Node to return is equal to head right here, because we know there's going to be at least one value that we would return. If we're in this if statement, that means we're going to go ahead and set head equal to null. There's nothing else in the list, so removing it effectively says that. And then we'll go ahead and return node to return. That's the guy we removed. So what we just did there is this move. If we have a one list, so that is if head points somewhere, which it does here, we'll go ahead and set, this is called node to return. In this example, we'll set node to return equal to head. Then we ask the question, is head's next node equal to null? In this case, it is. Is head's next node equal to null? If it is, that means we have a one list. So what do? We set head equal to null, effectively removing the one element from the list, and then we return node to return, the one guy we just took off the list. All right, that handles our one list special case. Else, there are at least two nodes in the list. So we can do our normal pattern. So our normal pattern, if we put this guy back in, says if node to return has a next node, and actually this would probably be, well, we'll just keep using it instead of the cur node thing. If node to return has a next node, which he does, and that next node has a next node, then we'll go ahead and traverse. So we'll go ahead and give that guy an extra next node here. So there's another node up there. So what we want to do is we ultimately want to get this guy positioned at the node right before the last node in the list. So does node to return have a next node? Yes. Does his next node also have a next node? It does. So we can go ahead and jump him down the list once. Both of those conditions need to be true. Does node to return have a next node? Yes. Does his next node have a next node? It does not. So we're where we need to be. All right, so that's the next logic we want to write. We want to write the thing that positions node to return to the right place. So, in fact, actually, let's just do it with a cur node. So we'll say node cur node is equal to head. That way we'll just update node to return for the actual guy we want to return. All right, if we're in here, we know there's at least two lists, so we're going to say, or two nodes in the list, so we'll say while cur node dot get next node is not equal to null. So as long as he has an X node and cur node dot get next node dot get next node is not equal to null. Does cur node have a next node? And does his next node have a next node? If both of those things are true, then we'll say cur node is equal to cur node dot get next node. Bump him down the list. So now when we're here, cur node points to the node right before the last node in the list. Make sense? That's where we're positioned right now. So we ultimately want to return this guy. So that means the very next thing we need to do, so right now this is called technically, things currently look like this. So node to return is still pointing ahead from the previous if statement. Cur node started off at head, moved down the list, so he's positioned one node before the last node in the list. Now we can go ahead and say node to return is equal to cur node's next node. Right? We need to preserve that guy so we can actually return him. Node to return is equal to cur node dot get next node. So that does this. Then we're going to say cur node dot set next node to null. Disconnect it. All right, so that disconnects it. Then we can finally return node to return. That make sense? So this guy ultimately gets returned, and our list is left one node short. So our current code is showing a list that's 6, 7, 8. So let's go ahead and remove end. So the next guy should be 6, 7. Notice I'm not actually doing anything with the node that's being returned right now. I'm just removing it. Then we say ll.display. So now the very last list that's shown on there should be the list 6, 7, because we removed the 8. So there's our 6, 7. That make sense? All right. So those are all the easy moves. Those are all the easy things we would do with a linked list. So now things get a little bit weirder. What if we want to add something in the middle of our list? So we want to add something at a specific index. Let's go back and just move this down a little bit. We'll have this guy point here. We'll set this pointer to the side in case we need him again. We'll set this pointer to the side. Hopefully you're seeing here with this these linked data structures that it's extremely helpful to draw pictures. All right, so in fact, it becomes fairly easy as long as you draw the pictures and write the code one step at a time. Because then you'll know, okay, well, I just did this. Everything looks like it'll be fine if I write that one line of code. Go and write the one line of code, do it one step at a time like we're doing. But it really requires us to think about it visually like this so we know when we're disconnecting one pointer, have we lost what we're pointing to? So we're going to go ahead and assume our linked lists are indexed like an array. So this is bucket 0, this is bucket 1, this is bucket 2. All right. So for right now, why don't we go ahead and get a node from a specific index. Fair enough? Let's go ahead and grab a node from a specific index. So we're going to go ahead and we're going to write a function in linked list. Public node get at index int I. All right, so this is going to return the node at position I in our list. Okay, so we need to try to traverse our list as far as we can and get to bucket I or return null if we couldn't get there, right? Now, having said that, would it be beneficial for us to know how many elements are in a list? If we could keep track of that our list currently has 3 elements in it or 2 elements in it, something like that, that would be helpful. So how could we modify our linked list to keep track of how many elements are in it? I mean, one way we can do is this. So we can say public, let me just return null for a second here. Public int count. So we'll say int count is equal to 0, and now we're just going to walk our list as long as we have nodes. So we'll say node kernode is equal to head, while kernode dot, well, we'll just say this. If head is equal to null, return count. Else, we need to do some stuff before we return count. What will we do? We're going to go ahead and set kernode equal to head. And if we're in here, we know we have at least one element. While kernode.getNextNode is not equal to null. Kernode is equal to kernode.getNextNode and count plus plus. As soon as we're done with this, we can return count. Okay, we can write this, I guess, a little bit more efficiently by saying if head is not equal to null, do all this stuff, in the end, return count. So count's going to start a variable off at count. As long as we're not dealing with the empty list, if we are, we'll just drop right down and return the current value of count, which is 0. But as long as we're not dealing with the empty list, we'll go ahead and set kernode to point to the same thing as head does. We're going to keep moving kernode down the list as long as we have a next node. Each time we're going to increment the number of nodes we ran into. So this would calculate count for us, correct? All right. How else could I get the count of a linked list? Would you say this is very efficient? Every single time I want to know how many elements are in the list, I have to calculate it, right? Go ahead. Okay, so I can add a field into our list here. Private int count. Start count off at 0. All right, and then what would I do? Whenever I actually add something, add 1 to it. Whenever I actually remove something, remove 1 from it, right? So now we can come down here, add front. Count plus plus. Steal this line real quick. Actually, I'm going to say this dot count plus plus just because I like that. when I remove front, as long as I'm actually removing something. We'll say minus minus. Be careful not to haphazardly remove, minus minus even when you didn't actually remove something. So I'm only decrementing it if I actually took something off the list. Add end, well, if we get into this one, add front's already incrementing count for us. If we're in this else, we're going to move into the position, and at the end of the day, we'll say this dot count plus plus. Remove end, only if we actually remove something. So if head is equal to null, we're not removing anything. Otherwise, do whatever it is we're going to do. Either way, something gets removed here, right? And we'll say this dot count minus minus. My inside of oh, that's not gonna fly. We need to put it at the top there. If I'm in this else, I know I'm going to return something, so I can go ahead. I know I'm going to remove something, so I can go ahead and decrement it right there. Either one of these actually removes something and returns it. Okay, so now we're able to keep track of our count, really two different ways. All right, we can ask for the count field locally, or we also have a way of calculating our count. They'll both ultimately give us the same answer, except this guy right here is pretty inefficient because it's actually going through and every single time we want to know the count, it's going through and literally counting all the elements in the list. All right, so we can say this is inefficient but accurate. All right, and let's kind of prove that's the case right now. Just real quick, I'm just going to make this guy public so we have direct access to him. And then what I'll do is here in main activity, after we display, I'll do a system.out.println, put a couple asterisks in here, and we'll say ll.count. So that's the one we were keeping track of the whole time. And then we'll do a system.out.println ll.count. There's our function that calculates. And both of these guys should spit out the same number. Okay? And we'll see it down here. That's why I put the asterisks in there. Oh, I don't have to run it here. Just okay, one of them gave us a 2, the other one gave us a 1. That was our calculation one that gave us a 1. The one that's correct is the first one. So our calculation one was not written properly. Count is equal to 0. If it's not equal to, well, if we have a head is equal to null, we'll return 0. Otherwise, cur node is head. Oh, we didn't count the very first guy. So if we're in here, we need to say count plus plus right off the bat. We have at least one, but there might be more. So now they'll be the same. There's our 2 and 2. Okay. So a couple different ways of getting the count. Now let's go ahead and update our link list to, well, we're going to make our buttons do some stuff. We're going to give ourselves a text field up here. And this text field is going to be to add an element, and we're going to have a couple different buttons. Add front, add end right now. Okay? And then we'll have another couple buttons for remove front, remove end to do those moves. And then we'll have it go ahead and fix our list, adjust our list. So we're going to go back to, in our display guy here, remember last time we had this commented, well, I commented out, this redoes the list every single time we tell the list to display itself. All right, so now we should always see the current version of our list at the bottom. So let's go ahead and let's add some stuff here to our this guy. So right now we have this press me button. Do we still have a press me button clicked? Yeah, we do. We have this guy. So let's add a couple more of these guys. So we're going to have a add front button clicked. Actually, let's do it all with a single button. So we'll call this a button clicked. And this guy takes in a view that is our sender. So we're going to be able to ask the question, if the sender was the add front button, do this. If the sender was the add end button, do this. If the sender was the remove front button, do this. So on and so forth. So we'll only have one function to handle all of those button presses. That way we'll see how this guy is used. All right, so let's give ourselves the buttons first. Let's go out here. And let's see, do I have what kind of layout do I have up there? All right, I have a vertical linear layout up there, so I need to go ahead and add a couple of things. So this whole thing is governed by a vertical linear layout, and in that I have our button and I have a scroll view. So I'm actually going to go ahead and give myself another vertical linear layout inside of this vertical linear layout. And then inside of that vertical linear layout, I'm going to give myself a horizontal linear layout. I want this guy to be inside of that guy. And then I'm going to give myself a second horizontal linear layout. So kind of 2 rows in a vertical column. All right, and now I'm going to go ahead and we'll have to resize some of this stuff, but for right now, I'm going to throw some buttons inside. Well, actually, that top one's going to have a way to enter some stuff in. So we're going to have a plain text field. That'll be inside of that guy. So that's going to be an edit text. Drag that out. All right, and then the second guy is going to have a bunch of buttons in it. Okay, and we're going to rename these buttons to some stuff. So that's button 3. You're going to go down to ID. So we're going to name that guy add front button. We'll name this guy add end button. We'll name this guy remove front button, and we'll call this guy remove end button. Now let's put some text in each of these guys. So this is add front. This is add end. This is remove front. This is remove end. Okay. So that's our first linear layout, and let's go ahead and resize that guy up to there. Here's our second linear layout. Let's go ahead and resize. It looks like we might benefit from having two linear layouts up there for horizontal ones. Just throw another guy right above here. And we'll add a couple of we'll have our add buttons inside of this guy. And then we'll have our remove buttons inside of this guy. I don't think that's what I wanted. Here's vertical. Here's our first horizontal that has our text field in it. Here's our second horizontal that has our remove buttons in it. And where did that other guy go? Oh, here he is. I can't get it to land in the right place. Alright, so now are they in the right places? That's the vertical. That's horizontal. Alright, so this is one of those examples where we go in here to the text. Here's our vertical linear layout. So the whole thing's in a vertical linear layout. Here is our next vertical linear layout. Inside of there we have our first linear layout with the edit text in it. Then we have our second linear layout with our couple of buttons in it. Now I want our third linear layout, and this is the guy that has our add front button. So we actually want this guy to come before our remove ones, I think. So I'm going to take that linear layout there. I'm going to cut it. And we're going to paste it right here. So now inside of our vertical linear layout here, we have three horizontal linear layouts. One with our edit text, one with our add front, add end buttons, and then one with our remove front, remove end buttons. All right, and then here's that other old button that we don't need anymore. All right, so kind of see a situation where editing the XML was helpful. We don't want to have to do that very often, but rather than sit there for 45 minutes trying to get the thing to land in the right place, this was the easier thing to do. Okay, so now I should be able to. There's that guy, there's that guy, so let's resize him to be the right height. There's that guy, and then we finally have our scroll view, which is down here, and we should be able to bump him up to, oh, actually was, maybe he's already when he needs to be. Okay, so let's go ahead and for our three linear layouts here, let's set the gravity equal to center. So all of our buttons will just be centered on the screen. No good reason, just that's what we're going to do. And then for our text field up here, our edit text. We can give it, I think there's a placeholder text. Well, we definitely want it to be editable. Definitely want it to be enabled. Now let's just put some text in there for right now so we can see it. So there's new value. And then let's set the gravity for this guy as well so he's centered. So our text will be centered in there. Okay, so that'll be our new value that we'll get put in. But for right now, let's go ahead and give ourselves access to these 4 buttons. So programmatic access to those. Let's go back in here. We'll go to our main activity. So up top here, let's go ahead and give ourselves access to a couple of buttons. So I'm going to create some private fields. So private button, add front button. Private button, add end button. Private button, remove front button. Private button, remove end button. And then we're going to have private edit text, new value, edit text. We'll import that guy. All right, so now those are our starting points here. So now we got to go ahead and give them their values. So we'll do that inside of onCreate. Give ourselves programmatic access to the buttons and edit text. So we'll say this dot add front button is equal to this dot find view by ID r dot ID dot add front button. And this guy is going to give us a thing of type button. Copy that. Add end button. Add end button. Remove front. Remove front. Remove end. Remove end. And this dot new value is equal to the edit text version of this dot find view by ID r dot ID dot we call that guy out here. Maybe do we even call him anything? No, let's give him a name. New value ET. All right, so now we have programmatic access to all those things. So now down here, we need to go ahead and let all of those buttons know that their on click should call this guy. So I'll connect all of those, and then we'll go down to on click, paste that guy in there. All right, so now they all should have an on click for that same function. Okay. Now we'll go back in here. So now we'll ask which button was pressed. If sender is equal to this dot add front button, we'll do a system.out.println add front button pressed. Else if add end button pressed. Else if remove front button pressed. Else if remove end button pressed. So we'll just spit out which of those buttons was actually clicked. All right. So we know we're responding to our interface correctly. All right, so here's our couple buttons. So we'll hit add front. Then we'll hit, you can see it says add front button down here. Add end, remove front, remove end, add front, remove front, so on and so forth. So now we're responding to those various button clicks. Now I'm going to go ahead and when we hit add front or add end, I'm going to spit out the value that we had typed in here. If we do either of the add ones, whatever we currently have in that edit text box, it'll read in using the get text method from that edit text box, and presumably we would then be able to add it to our linked list. Say 14, there's add front, adding 14, add end, adding 14, 7, add end. But if we do remove front or remove end, it doesn't show the adding thing. Okay? And I think you just saw there that we can have this not have a value in it, and it'll just have that line so it's empty, kind of ready to take in some text. All right, so for your homework assignment, make this work so that add front, add end, remove front, and remove end update the linked list and show the new thing in the screen at the bottom. That makes sense? And I already have that one line uncommented, so every single time we add something to the front, the entire thing should update when we call display. Make sense? You won't just have the multiple lists now, so the bottom should be the current version of your list. All right, so I will see everybody on Tuesday. And on Tuesday, we'll start writing remove front, or I'm sorry, remove at index and add at index. Okay, so you're not doing that for your homework. You're just doing this interface stuff for your homework. And I'll go ahead and push this to Yep. But just for a little bit because we have computer science meeting at 11:45. But I'll be down there for starting right now. Let's see. Do I push this to... What do you think? Do I create a branch for homework 5 now and push this there as a starting point? 5.
I have a question for you.
Mm-hmm.
If I wanted to take 50 right now, could I?
If you wanted to take what?
350? Like register for the class?
I guess you could do it online.
I mean, I could. It would have to be online, not that much, but I would be able to, right?
I'd be okay with that. I think you'd have to take it as a independent study.
What is it?
So you would have to fill out the independent study form since we don't offer 350 this semester. So there isn't a class for you to sign up for. Oh, here, let me stop the recording.